Hi all. So today we are going to see Officer on Watch, Stability and Operations, SQA, July 2023, question number 2. So question number 2. A vessel is floating in salt water at drafts forward 3.600 meter and aft 4.100 meter. The vessel's kg is 9.20 meter and LBP 137.50 meter. Part A. Part A. Using datasheet hydrostatic particulars, calculate the position of the ship's longitudinal center of gravity (LCG) at these drafts. Part B. Using worksheet Q2 for the vessel in the trimmed condition, indicate the position of each of the following. Number 1. Center of gravity as calculated in question 2A, showing the weight force. 2. Center of buoyancy, showing the buoyancy force. Part C. Calculate the vessel's longitudinal center of flotation for the vessel's condition and indicate this on worksheet Q2. Now let's look into the answer for part A. For part A, draft forward is 3.600 meter and aft is 4.100 meter. This is given in the question. So with this, we need to find the trim. Trim is the difference between forward and aft draft. So that is 0.5 meter. That is by stern. And now we need to find the arithmetic mean draft, AMD. So that is forward draft plus aft draft divided by 2. That will give you AMD is equal to 3.850 meter. By keeping this AMD, with this AMD, you need to check the hydrostatic particulars. And keeping this 3.850 as reference, you need to find the LCF from the hydrostatic particulars. So you will get the LCF as 69.91 meter from the hydrostatic particulars. And then LBP, length between perpendiculars, is given in the question, 137.5 meter. And with all these values, you need to find the true mean draft of the vessel. So true mean draft is given in the stability formula sheet. So true mean draft is equal to draft aft minus trim into LCF by LBP. So that will give you a true mean draft of 3.845 meter. So from the hydrostatic particulars for TMD obtained 3.845 meter, we need to check, interpolate and find out displacement, MCTC and LCB. So displacement from the hydrostatic particulars is 7576 tons, MCTC is 148.2 and LCB is 71.2. And the formula for trim we will get from the formula sheet, that is trim is equal to displacement into LCG difference LCB divided by MCTC. So after solving this equation, you will get the LCG is equal to 770.22 meter. So here, what you need to keep in mind is that in this case, the LCB will be greater than LCG because the trim is by stern. Let's say if the trim is by forward, then LCG will be greater than LCB. So this you should not forget. So hence here we got the LCG is equal to 770.22 meter. So coming to the part B of the question. Part B, number 1, wants us to indicate the center of gravity showing the weight force. So center of gravity G has been pre-calculated in the previous part and the value is 70.22 meter. So this is the center of gravity. It is LCG in this case. So the weight force is indicated with a down arrow. So the weight force always act downwards. So that's the W of symbol and arrow. And number 2 wants us to indicate the center of buoyancy, showing the buoyancy force. So the dot just in front of uh, the LCG, that is the center of buoyancy. So the center of buoyancy, B up, the force act before. So that is given by this arrow. And the next one is part C. Part C wants us to calculate the LCF and indicate it on the worksheet. So LCF, with the help of true mean draft, we need to go to hydrostatic particulars and we need to interpolate and find out the LCF. So LCF is 69.91 meter, and we have indicated it with this dot here. So that's LCF is 69.91 meters. So that's question number 2. Thank you.